Hello and welcome to our lab on electric circuits. Today's lab we're going to be basically becoming familiar with the terms used in circuit analysis and also making you comfortable with designing, assembling, and making measurements on a simple electric circuit. So first of all, let's talk about some of the terms we'll be using for our measurements. To begin with, we'll be measuring voltage. Now voltage has units of, voltage is V, the quantity is designated with a V, but it also has units of volts. Go figure. Also designated by a V. And so I'll put my brackets here to indicate that's a unit, and the parentheses, let me let that indicate that it's a quantity. So voltage V is measured in volts, also V. And so my typical volt measurement may look like this. I have a voltage V that's equal to, I make my measurement and I might say it looks like 12.6 volts, plus or minus maybe 0.1 volts. So this will be a typical voltage measurement. Now another thing we're measuring is current. And so current, electrical current, has a short name of I. However, the units of current is the amp, sometimes the milliamp, but the amp is designated by the letter A. So let me put that in brackets to show you that it's a unit. And so a typical measurement might be, I have a current I that's equal to 0.123 amps, plus or minus 0.001 amps. That might be a typical current measurement. Another way to state that would be 123 milliamps, or little m, capital A, milliamps. Now last of all, we're going to be talking about and measuring resistance. Resistance has a quantity R, resistance R, but it's measured in units of ohms. And it's the capital omega here, a horseshoe, upside down horseshoe, I guess. And so a typical resistance measurement, you might say, my resistance is equal to 1230 ohms, plus or minus 10 ohms. And so that's a typical resistance measurement. Another way to state that might be 1.23 kiloohms, small k, big omega, 1.23 kiloohms, or 1.23 thousand ohms, plus or minus 0.01 kiloohms. That would be another way of writing this same measurement. So those are the basic quantities that we're using here, and in terms of their units. Alright, let's talk about a circuit diagram. Now, the circuits that we build will be made of real components, and I'll show you those in a few minutes. But first of all, let's look at it sort of schematically. Now, if I have a circuit, first of all, I need a battery. Now, believe it or not, here's what the battery looks like. A long line over a short line. The long line indicates that this is the positive side of the battery. The short line indicates that's the negative side of the battery. And to make a complete circuit, we'll take our wires, and our wires are just the lines that I'm drawing here, and then we'll loop it around. This is actually really bad for the battery. It would cause the battery to drain very quickly. The wires might even heat up and melt because of all the electrical current flowing through those wires. So we normally want to put some sort of a load on the circuit that's not as big as the load of just these wires. So we'll do that by putting in some sort of resistance to slow down the current. And the resistance can look several different ways. It can be a jagged line like this. This might indicate a resistor in the circuit. Another way to draw a resistor is using more recently a rectangle. This indicates a resistor, and you might write the value of the resistor in there. It may be 10 ohms. And so, however, in today's lab, our resistors are going to be light bulbs. little lamps that we use. And so the schematic for a little lamp looks sort of like this. And that's our resistance in the circuit. That limits the amount of current, and now your wires won't heat up and your battery won't drain. And so here's our resistance, R, of the light bulb. Back to the power supply, this battery, we're using 4 D-cell batteries in series, and so it's roughly 6 volts. So our voltage is roughly 6 volts. Now, however, we'll be making more accurate voltage measurements using a multimeter. We're going to have very special measuring devices. But here's your basic circuit. Now, let's say we wanted to make some measurements associated with this circuit. Well, 2 things I might like to measure are voltage and current. So I have a device I can use, and I'll show you how it works. But when you're measuring voltage, you measure voltage from one point to another. It's basically you're going to measure the voltage. If you want to know the voltage across this resistor, you measure the voltage on one side and subtract from that the voltage on the other side. And so you're basically getting a voltage difference. And so we can measure it more directly by just attaching a voltmeter to that. So I'll draw a little V here. And this is what a voltmeter in our circuit looks like. We're measuring the voltage from here to here across this light bulb. And so we attach it by wires from one point to the other. However, let's say we want to measure the current that's flowing through these wires and through the light bulb. In order to do that, I can't put it across right here because that's not going to effectively measure the current. I have to measure the current as it's going through the wires. So I have to break my circuit, which I didn't have to do with the voltmeter, and I have to put my current meter right in the circuit so that the current flowing through this wire has to go through the current meter in order to for that to be a complete circuit. So now I can measure current like this in the circuit. I can measure voltage across any element in the circuit, and those are my measuring devices. All right, let's talk a little bit about the apparatus. Now, first of all, our power supply. This is a group of batteries. It's 4 D-cell batteries. They're around a volt and a half each, so sum them up, that's around 6 volts. You look at the ends, you can see which one's negative, which one's positive. So when you draw your schematic with the short end on the negative and the long end on the positive, that's this, the power supply. Now, you've got these alligator cables, which are your wires, your connecting wires. They're conductive. They're called alligators because they have little teeth that open and close. Now, I can connect one to the positive terminal of my battery. I can choose another one and connect it to the negative terminal of my battery. And now I have most of my circuit. I don't want to connect this because it'll overheat the battery and the wires and too much current will flow. I'll limit the current using a resistor. My resistor will be a light bulb. Here's my little lamp. Now there's a sheath around the outside, a conducting sheath, then an insulator, and then a conducting tip. And the way this lamp turns on is electricity goes from the conducting tip through the little filament inside and then back out to the sheath and on. So the way I connect that is I have this little lamp holder, and it has 2 layers here. One terminal to the lower layer that connects to the little tip of the bulb, and then this higher layer, it wraps around the sheath and goes out the other terminal. So now I can thread that in, and so now both are connected. So now when I take this and I attach my wires to it, electricity will flow, and I've got my light comes on. So now I've built my simple circuit. Now I want to do some analysis on it. So I'll use my multimeter. Now the multimeter, let's say I want to measure a voltage. So I'll take these two terminals. Now to measure voltage, I like to use this type of probe. You can touch it from one point in the circuit to another and measure the voltage. So on the other end of this probe is a sheath banana plug. It's inside of here. And the jack for that is right here in the meter. So I can attach, I'll attach the black lead to the common terminal. Okay, this is common. And this is the reference point from which I'm going to measure my voltage. And the red lead I will attach here in the volt ohm terminal, volts and ohms. Yours may not look exactly like this, but all multimeters have these same type of terminals, volt ohm. And then I can measure my voltage. So first of all, let's set the setting. It's off right now. The first choice I have is alternating a voltage. It's the voltage with the little sine wave beside of it. That's not what I want. This is a battery. This is DC. So let me turn it to DC voltage. Now I can take these terminals and I can put it on either side of my little lamp here, and I'll measure a voltage. Here I'm measuring 5.85 volts DC. Well, that's great. So I know the voltage that's across this lamp. Now what about the current? Let's say I wanted to measure the current. Well, the way I would do that now, I can no longer measure across it and get the current. I have to become part of the circuit. So I'll have to reset up the way this meter works. Let me unplug these cables. And for current, I want to use a couple of banana cables like this, because then I can attach it more firmly. So I'll take these banana cables. On the other end here, you see that they're just banana plugs, but I have some alligator jacks that I can attach to the banana plugs, and now these nice cables become alligator cables as well. So looking here again at my circuit, I need to attach this in there somehow. Now before I do that, I want to make sure I'm going to measure the right quantity. So it's on DC volts now. I want to change it around. Here's the ohm setting. We'll talk about that. There's alternating current amps with a little sine wave, but I want direct current amps that'll work like the battery. So we're in direct current. And when I'm measuring amps, I don't want this red wire in the volt ohm connector. I want it over here in one of these amp measuring connectors. I'll put it in the 300 milliamp because I'm measuring small amps in today's lab, small currents in today's lab. For a large current, so I'd put it up here in the 10 amp setting. Alright, now I want the current from my circuit to go through the ammeter. And so I'm not just going to measure to the outside like I did with the voltmeter. So I'm going to just totally remove this wire. And now from the other side of my bulb, I'm going to go in like this. So the current now has to go into my ammeter and out the other side of the ammeter to the battery. So the light comes on again, but now the ammeter is part of the circuit and I'm reading a current 139.6 amps. And so that's plus or minus probably 0.1 or 0.2 amps. And so that's how I make my measurement. Last of all, if I want to just measure resistance, maybe I just want to know the resistance of my load here, I can turn the meter so that it's reading, it's on the ohms range. Ohms. And now I take this and I put it back in the volt ohm connector over here. So I'm measuring volts or ohms, I use this one. If I'm measuring amp, I use one of these. And now I just connect it across what I want to measure. It's important that power is not connected at this point, because if I had power connected at this point, I could damage my meter. And so the resistance of that cold light bulb looks to be about 5 to 7 amps. 5.7 ohms, sorry, 5.7 ohms. And that resistance actually goes up when it gets hot, when it heats up and turns on. So that's my apparatus, and those are the basic connections. And so the last part of this video will tell you the different types of connections that you can make using this apparatus. Okay, so now that you've been introduced to the apparatus, some of these schematics may look a little more familiar. Here is our battery pack, plus and minus. Here are the alligator wires coming around. And then here is our lamp that's connected through to the circuit. And so what we had done is we measured the voltage from one point in the lamp, from one side of the lamp to the other. And then we also, after that, we took the voltmeter away. We changed the voltmeter into an ammeter by dialing it around and moving from the volt ohm setting over to the 300 milliamp setting. We replaced that alligator with just the cables from our ammeter, and we called it an ammeter, A. So our multimeter became an ammeter. So that was the two different types of measurements we made. Now, let me talk about the two different types of circuits we're looking at. This is a simple circuit. Now, if we put another lamp in here, let's say there's another bulb over here, the current that flows from one part of this circuit to the other must go through both of these lamps. And so they're said to be in series. These lamps are in series because the current must pass through them serially, one after the other. Now you can design your circuit so that the current doesn't have to go through both of these. It can decide, okay, if we wanted to give it a personality, decide which way it wanted to go. So in this case, I've got two different branches, and the current coming from the battery splits and goes through one or the other branch. So there's a split in current. This is called a parallel circuit. And so in today's lab, you'll be analyzing series circuits, looking at some voltage and current measurements associated with both of those. You'll also be analyzing parallel circuits, if we get that far, and determining some of the voltages and currents associated with a circuit that branches into two different ways before it comes back together again to return to the power supply. So most circuits you'll work with in the lab can reduce to a series or a parallel configuration. So good luck with today's lab on electric circuits.